welcome to Ladyada.
Hey everybody, welcome to my desk. It's me, Ladyada. With me is Mr. Ladyada on camera control.
Hello.
Yeah, some updates from my desk, some samples. We're back to a normal schedule this week. We've been kind of back and forth a little bit, but we're gonna have this and the Great Search. So any news or updates you want to give people, Phil?
No, just we're riding the wave every single week, being the water that flows into the container that is provided for us. So should be, just trying to chill. Because every week is a new and interesting challenge with part shortages, with international affairs, with all sorts of things that make doing engineering just part of the puzzle that we get to solve every week. So, Ladyada, what is on your desk this week?
Okay, so this week I got a cool sample I thought I'd show off and do a little bit overhead. I got a couple different OLEDs, and this one, let's see, this is a clear OLED.
That's cool.
So, I do a lot of displays here, and it's like there's always more displays to cover. We've got OLEDs and TFTs and sharp memory displays. This is kind of interesting. So, I think that this is, it's not going to be like super bright, but I think, one thing about OLEDs is that they don't need a backlight, right? They self-create the light. And so this OLED doesn't have a backing to it, and so that each individual pixel should light up. So it's got like a 24-pin connector, and I think it does I2C and SPI, and it's like an SSD chipset. So even though it's I've never used this, I don't think it's going to be too hard for me to put together a quick breakout for it. And probably the breakout, will be separate. Like this won't have a PCB behind it because you'll want to, you probably want to mount it somewhere to have it, backlit and all that good stuff. So. From whatever you want to make. So this is a sample I got. Another thing, I'm working on this week is we're doing a lot of revisions and updates. You've noticed on the Adafruit site, there's a lot of lockdowns and shutdowns everywhere, so not a lot of products coming in, especially from other makers. Like we've booked orders and stuff is still being made or not in yet. But we are, doing a lot of revisions for our own products, updating them to use parts that we can get. And also just making what we can. One of the chipsets that I can get a lot of is stuff from Espressif. They're whatever, they've either booked time ahead of schedule or they've bribed TSMC with donuts or whatever, but they're able to get parts. And so we revised the ESP32 S2 feather this week, and I think we even might have a couple left in stock. So this feather uses ESP32 S2 mini module, which has 4 megabytes of flash, 2 megabytes of PSRAM, and it's perfect for a feather. You see, it's like it fits nicely with plenty of space for like STEM QT and LDO and some buttons and NeoPixel. I think this might have a NeoPixel demo running on it. We'll see. Maybe not. But here, I can put it in bootloader mode so you can see it light up. We've got NeoPixel and LED and battery charging and all this stuff. And I really like the S2. It's a good chipset. And I had to revise this feather because I made a mistake on the previous version. This board has a BME 280, and I had the pull-ups going to the 3-volt line instead of being controlled by the power control switch for the QT. And so when trying to go into deep sleep mode, if you had external I2C sensors that were high current, they would draw current from the QT port through the pull-up resistors and kind of self-power this having high current draw. That's fixed now because we have a totally separate regulator. And then once I fixed this, one of the things I designed, if people remember, is I made an S3 version of the feather. It's basically identical pinout. The module is identical pinout. The chip is not. But with the mini module, the S3 and the S2 are like almost identical. There's like 1 or 2 pins that are different. But the differences are there's like 2 extra pins basically. But I just didn't connect them anyways. So when we made the S2 feather, because I fixed, I actually had ordered the PCBs for the S3 feather with that earlier power mistake. And then I was like, I don't want to fabricate this and then have to fix it. So I just e-wasted the PCBs. And then when this board was run this week, I asked the machines team, hey, right before you put the last panel through, remove the module and put an S3 module there instead, because that'll give me like a beautiful, perfect prototype piece. Because it's like I don't want to have to hand assemble it. If I can have the pick and place do it and just swap out a board. So I did that. So this one is marked, you can kind of see it says S3. So this has an S3 mini module on it. So this weekend I mostly worked on getting this to come up. So this is actually running CircuitPython, I think. But one thing that's nice is, first off, we've got a lot better CircuitPython support for S3, thanks to Scott's intrepid hacking on the S3 and the S3 box. And also, Arduino added, espressif added Arduino support in their Arduino board support package in a branch. And so we were actually able to make the full test program as well, like all the code that I need to do to test the board. I was able to, I prefer to write that in Arduino and not IDF or, MicroPython or CircuitPython. I'm always willing to do it, but of course it's ideal to do it in Arduino because it's fast and it's consistent and it's very reliable, but mostly it's very fast. And so I got that going, and I've got a tester made. This tester is actually from a while ago because, again, I ordered the PCBs and then, realized that I had made a mistake with the design. So this is the tester, and you can see it says ESP32 S3, and then you plug in the board and you put it down on the test, the testing area, and then I press the test button. And it goes through a full test of all the hardware and programs it. So this is actually ready to fabricate. So I ordered the PCBs for this. And because it's the same, because that mini module is identical, the pinout and the shape and the stencil and the program is the same as the S2. You can see here it says it passed. It tested all the GPIO. And then it's got a little bit of a rainbow swirl to show that it's working. This should be really fast to get into the store. The modules I got don't have PSRAM. They have 8 megabytes of flash, but that's just because that's what was available. That was kind of the first thing that espressif released. But they did tell me they're going to have a version with PSRAM, so I'll make another version of this board when the PSRAM version of the chip comes out. But the S3 has 512K of SRAM compared to, I think, maybe 320K on the S2. And so already it's got way more RAM. So CircuitPython without PSRAM on the S2 is you can do stuff, but it's hard to do Wi-Fi things. You run out of memory very quickly. But on the S3, even without PSRAM, I was able to run a bunch of Wi-Fi programs, no problem. Nothing huge, but you can read you can have an extra 100 or 200K of SRAM left over for doing Wi-Fi stuff. So this is that tester, and then I'm going to just shut this down. Any questions?
Nope, keep going.
People have? Well, I thought I could show real quickly. So this is shut down. So I'm going to put this away, and I'm going to leave this with the machines team tomorrow. This little tester jig you see with the plastic. So that's good. So the next thing is the Cutie Pie board. So this also I designed. And I had it ready, but I made a small mistake on the board. And then also there was no Arduino core support, and CircuitPython was iffy. So I wasn't quite ready to release this. But now I am. So I thought I'd show how I'm going to add Arduino support to the board support package. It already has CircuitPython, so I'm not going to go through that. But I'll show how to do Arduino support for this so people can see what's it like. So let's go to the computer. And first off, I do want to mention, if you want ESP32 S3 stuff, they do have chips and modules in stock right now. So yeah, so if you want this module has 32 megabytes of flash and 8 megabytes of RAM, which is kind of ridiculous, but it runs like a full computer. So that is available. So the first thing that I do when I want to get a board working is you start with the generic definition that espressif makes for their dev boards. It's full featured, but it's in there. So first off, I'm in the branch, I'll show you. So I'm in a, if you see in the bottom right, I'm in a branch called ESP32S3 support. So they made a branch where they're doing the work. It's not 100% ready for people to use, but it does work. So if you just want to bring up your board, you can use this. So I went to this branch, and I got the toolkit that ran the get tool command to download the compiler and everything. And then in the in here at the top, where they have at the very top, they have all their dev boards at the very beginning. I picked the ESP32S3 dev module. So again, it's the generic definition. So then you have to go through and you have to like pick all the setup. So upload speed doesn't matter. USB mode. So hardware CDC and JTAG. This is actually similar to the C3. I can tell that they reused that. So the ROM bootloader is this hardware serial. If you don't, it's not on the go. It's actually a separate like ROM, CDC and JTAG OpenOCD debug tool. So just to get started, I'm going to just use that and not the USB on the go. I'm going to disable the USB CDC. I don't want mass storage. I don't want this DFU on boot. I do want to set the upload mode to use the internal USB, which is not the default. And that's because I'm not using a separate USB serial converter. And then everything else, flash size, I actually didn't change that because you have to set up the partition if you want something different. I didn't change the partition scheme. No PS RAM on this chip, so I made sure that's off. And then I put the board into bootloader mode by holding reset boot and then reset to have the COM port. And you'll notice it says ESP32C3 dev module. That's that hardware CDC JTAG built-in setup. So the next step, I have a little blink program that I like to run because it blinks a pin. I just set the pin at the top. And it can also test out the serial port. And so because it's not my board definition, I have to use the hardware GPIO pins. So the S3 QT uses the same pinout as the S2, and so I can look up here what's the GPIO name, because I call it SDA, but it's really GPIO 7. So I'm going to start with A0, which is GPIO 18. And then I've set up here that the LED is 18. I make sure everything is good here, and then I click upload. And then, meanwhile, over in the ESP32, because it's going to take a while to program, under boards.txt, that's where you add new board definitions. And you see there's hundreds and hundreds and hundreds of board definitions. And you can start, what I did for the Feather is I actually started with the ESP32S3 dev module, and I kind of copied that around to make the Feather S3. Okay, so this is done uploading. So then when you go to the overhead, can you go to the overhead real fast? Yeah. So usually I use my scope. Let me get my scope. Okay, and hardware reset, and then I check on my scope that the pin is toggling, but you can't see my scope, so I will have a GPIO pin. So LED is blinking, so that means I was able to upload code correctly, which means now all I have to do is create that pin definition. Can you go to the computer again? So like I said, I started by copying the ESP32S3 setup, but I'm going to actually start, I'm going to copy my Feather setup because I did the chip on the Feather and the chip on the QT is the same like partition and setup. So I'm going to take this, beep, 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 and this is how you do hardware development. Copy, paste. Great. So then I just have to replace Feather ESP32S3 with QT ESP32S3. Boom. Great. So next up I'm going to, so change the name up here. Great. No PS RAM. The next thing I need to do is, I'm going to disable the Tina UF2 thing for now. We basically upload the bootloader for you, but I'm not going to do that at this moment because I have to get the bootloader ready. Okay, so make sure that the variant and the board are the same. I do have to set up the VIDs and PIDs, and I do that. I have a, in production, I have a CSV. Oh my God. Hide. Okay. I have a CSV, and at the bottom of the CSV, I can create basically new allocations for all our VIDs and PIDs. Sorry, all our PIDs for the VID we have. I actually think that I already did the cutie pie. Yeah, it's here. No PS.
You already got 2 questions.
Yeah. So here I've got I keep forgetting that my screen. Maybe you can make me a little smaller. Because I'm like kind of the entire screen.
Do you want me I could shrink you.
Yeah, because it's like I'm always looking forward and I realize that it's like half my screen is.
Yeah, can always shrink you down.
Yeah, shrink me down.
Yeah,
There you go,
that.
that's great.
Like that?
Yeah.
Okay.
So I've got
I should get a sound effect. Boop, 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 boop.
Yeah. This is actually better also for a great search because that way I'm not
Great.
trying to find me. I'm
Let
tiny.
it be said, let it be done.
Let it be done. Okay.
Henceforth, today, this is the new size of Ladyada.
I am small. Okay, so I've got the PID and the VIDs set up. So under boards, I just have to enter in that this is a different number set. I like to have a PID, for the bootloader, for Arduino and CircuitPython, all unique. And then the variant I have to set up, that's the actual tough part. There's the defaults. Some of these entries I might delete. Like, for example, you're never going to upload via UART 0, but for now, I just left the menus in, even though, like, I don't see how you could ever upload without using USB because we don't expose even the UART, I think. And the PSRAM isn't there, so, like, why even have the menu? But I kind of just wanted to keep it matchy-matchy with the S3 dev board because it's always easy to delete menu sections from the board definition file. Okay, so the next up, I have to create a variant. So in ESP32 under variants, I'm going to do the same thing I did before, which is copy and paste. Since I have a board that uses the exact same chip, find the closest thing to what you've got, copy, paste it, and then edit it. That's the easiest thing to do. So ESP32S3 feather, and then I'm going to change this to cutie pie. And then inside of here, so as I mentioned, there's the bootloader and the Tina UF2. So we do this little trick with espressif where every time you upload Arduino, because it erases the whole chip, it doesn't use the bootloader. It uses like the built-in like ROM ESP tool thing. We always upload the UF2 bootloader, so it's always there if you want to switch back and forth to CircuitPython or make a backup of your drive. So what that's all about. And then pins Arduino is where like the magic happens. This is where you actually do like the definition. So again, I need to do the PID correct, and my Arduino PID is 8119. I'm going to change the name. All the number of, I know it's like a number of digital pins. I actually keep that the same. And then there's no LED built in, so I remove that. And then what I do is I go through the pinouts and, whoa, hold on. I go through the pinouts and I add that to here. So for example, the NeoPixel power pin is GPIO 38. So here's 38, and the NeoPixel pin is 39. There's no I2C power pin, so I delete that. So that's that. TX is 5, because I remember reading the GPIO. RX is 16. SDA is 7. SCL is 6. SS is not really used, but I'll leave it at 42. MOSI is 35. SCK is 36. MESA is 37. I believe those are the hardware GPIO pins. That's why. we use that. And then A0 is 18, A1 is 17, A2 is 9, A3 is 8. And then, I like to have it A4, all the way around. So A4 will be the same as SDA is 7, A5 is 6, A6 is 5, and finally A7 is RX, which is 16, and then delete the rest. There's no more analog pins. For the touch pins, not a lot of touch pins are exposed. We only have T5, T6, T7, T8, T9, so I'm going to just delete this. T5, T6, whoops, T5, T6, T7. Hold on. T7. What happened here? My editor's weird. Okay, T5, T6, T7, T8, T9, and that's it. So delete the rest, and that's it. That's my variant. So now I'm actually done. So it's actually it's not so bad. So next time if I quit Arduino, I'll save that change and then I restart. Okay, and then are there any questions?
Let's do the questions.
Yeah, while I wait for Arduino.
Yeah, so the first question was, without the PS RAM, is the S3 faster or better than the current S2 Feathers?
It's going to be faster because there's 2 cores, but it's like better. It's like it doesn't have PS RAM. If you have a project that requires it, then you need it. It's like...
Okay. And then when you were going over the RISC-V stuff, person had a question, is that's a patent licensing benefit for makers?
Not really. It's kind of unique and interesting. It's going to be a little bit cheaper, but I don't know if for makers you're going to really notice a 25-cent difference.
Do you think, this is my follow-up question on that, do you think because the RISC-V architecture can be manufactured by others, we might have other companies licensing, putting their names on it, doing stuff instead of, like ARM architectures? Or
yeah, if you're making your own chips, it's easier definitely to put a RISC-V core into something than ARM core.
So it might seem more companies use that instead of maybe different choices that they had in the past.
Yeah, I mean it's
no
just
choices.
More choices for sure.
Okay, so more choices is good.
So now, if I did this right, which usually takes me a couple tries, so if I didn't get this right, that's okay. So under here, so now there's the Cutie Pie S3, and I can select it. And Arduino's going to be thinking about that. I don't know why Arduino runs very slow on my computer, but I also have like a ton of stuff installed. Okay. So now it should have everything kind of pre-set up. So it pre-sets up the internal USB and the flash size and the ports. So now what I should be able to do is if I select A0 as the LED, because I have a board definition that knows what these pins are, I should be able to upload it and the same pin will flash, but I didn't need to know the low-level GPIO, like number, like 18. I can just use the naming that's on the PCB itself. And then we'll go into the great search. Wait, there's an error compiling.
All right, well.
Oh, shoot, I forgot the variant file.
Well, we're committed, so why don't you do that?
Yeah, I'm almost done. No, I forgot. So for my other boards, there's a power pin. And I forgot that in the variant file, you can have a function called init variant, which is a weakly connected function. And so if you want to have something happen to your board at the beginning, that's where you do it. So I have, pin, for example, like the NeoPixel power pin, because people forget to set it high to enable the NeoPixel power, but by default, I have it off to reduce power draw and deep sleep. In the variant file, I turn it on, but I forgot to remove the I2C power pin because there is no I2C power pin. Okay, this is going to hopefully go. And then, once this is done, I commit and I do a pull request. And I found that if you do a pull request for new board definitions, espressif will merge it into the mainline branch very quickly. Although this is in the S3 branch, so it'll go to the S3 branch very quickly. And then they don't do releases very fast, so you will have to tell people, hey, you have to install from the master branch. Okay, so now it's uploading. So give it a second. Okay, upload. Okay, and then I hit the reset button to make sure, and then I have to get this LED. Okay, and then if you go to the overhead, I've got the LED blinking again. But again, this time is with self-defined board definition with all the pin names set up and the right amount of flash and everything. And so the last thing I'm going to do, which I didn't do yet, is in TD-UF2 I created, I think I even have already the bootloader definition, but I have to go and just verify it's still correct. And then have the bootloader file included in the Arduino board definition, and then I'll submit that PR. So when people get this board, they can just drag and drop. They don't have to know what to select in the menu. They just select QT Py, no PSRAM, and it's ready to go. They can just use the names on the silkscreen.
Okay.
I think it's fancy.
Do you want to do the great search?
Let's do the great search.
All right.
Where in the world is that part I need? The great search with DigiKey.
All right, the great search brought to you by DigiKey and Adafruit. Ladyada user powers engineering to find things that you're looking for on digikey.com. It is hard to find parts, but with Ladyada's help, you could probably find the things that you need. Ladyada, what is the great search this week?
This week, sorry, I was expecting you to say something else.
I was expecting to say something too, but then I figured I was kind of done.
Okay.
I was like, I think I've said it all.
Okay. So this week we got a little bit of a mailbag. Someone wrote in and they said, I want a 16-bit DAC, and I think you should have a STEMMA QT board because we have a 12-bit DAC board. And I was like, you're correct, we do. We don't have a 16-bit DAC board. And there are some times where you want 16 bits of resolution. We have 16-bit ADC. So let's go to the computer and I'll show all this stuff off. So we have a couple of different, we have 12-bit DACs. The MCP 4725 is a fine DAC. We also have the quad version, not in stock because you can't get this chip anymore. The 4728. So these are our two DAC boards. But there are people who want to use our ADC boards. We'll notice that we have 12 and 16-bit ADCs. So, they're more expensive. Like, once you get past 10 or 12 bits, you're definitely going to be paying more. But if you really need that resolution, you want 16 bits, you want 16 bits. So let's find a DAC board. So I'm actually just going to search for DAC. And there's a lot of DACs. And here's something to watch out for when you're searching for DACs. First off, there's a 2-bit DAC. That's just like a single resistor divider, guys. Like, do you really need a whole chip to do that? So for DACs, there's 13,000 of them. So let's filter out what we want. So, we want 16 bits or better, and we want to be surface mount because we want to put it in our STEMMA QT board, and we want it to be I2C ideally, so that we don't have to have any sort of converter or translator. So let's go to number of bits, and let's select. Well, there's like a weird 12/16, but we pretty much want 16 and up. So let's apply. Okay, so now we've reduced it to, and let's also look at only active chips because I don't care for the unactive stuff. So, and then, there's a lot of, like, look at these beasts, these monsters, but we don't want these. We actually really want surface mount only because we're going to put this on a board. Okay. So now we're back to normal. So one thing to watch for is a lot of DACs. DACs, there's actually kind of like two kinds of DACs. I mean, there's more, but there's kind of two kinds of DACs. There is, if I sort by price, there are, the CS4334, which is actually kind of a famous I2S DAC. So when you're looking for DACs, there's basically like three interfaces for DACs for the most part. There's the I2C, kind of slower DACs, but it's I2C, so it's very easy to integrate. There's SPI, and we've used SPI DACs before, like our Wave Shield to play WAV files. We could, you basically pump in SPI data, and the 16 bits gets converted to analog output. And there's I2S DACs. So technically anything that is I2S to audio is a DAC, but you do have to, you can't just send and set data. With I2S, one thing is that they're quite inexpensive. And so there's definitely going to be cases, by the way, if you are constantly setting an analog voltage, you probably could get away with I2S if you have the interface and you can stream that data out. But you have to continuously stream data or you're going to get like popping. Most I2S DACs do not like it when you stop sending data. They're not gonna hold that last value. Also, some of them have limitations on the voltage range. Some of them have limitations on how fast they can update. So there's a lot of a lot of times when I was looking at these DACs, there's a lot of I2S DACs. And I'll tell you another thing. Sometimes, it's very easy to, people mistype when they're categorizing these, and I2S and I2C, I make the mistake of I2S, I2C, I confuse the two. So just be aware when you're searching for these, this top one is labeled I2C, but it's not, it's definitely I2S. So the first thing is, I'm actually going to remove, and only look at 16-bit and maybe, dash DAC, because the 24 and 32-bit DACs are all the I2S DACs. So let me apply that. And then the next thing I want to look at is the interface. Hold on. The number of converters. So I want like one or two. And then the interface down here, because I want this to be for a STEMMA QT board, I really do want it to be, only I2C. I'll also pick up this dash here. But I don't want parallel or SPI or serial. Okay, so this is what I came up with. And so all of these were actually pretty good options. I'll say that none of them are in stock, pretty much, except for this one from TI. I did search, and this is, once in a while it's like, it's like I'm trying to pick a part that's in stock, but with these, none of them were. So given that none of them are in stock, I thought let's pick one that would be a really good option, and then I'll just sign up to be notified when it is, and then when it's ready, I'll I can get samples, and then I can maybe design it in. So for pricing, once you get to the higher pricing, they're basically the two options that seem pretty good are, if I want something in stock right now, this is the only one that was in stock right now. But this ADI one, the AD5693, actually looked like a very nice design. It has I2C. The voltage, analog, and digital supply is up to 5.5 volts, which is really nice. It's a voltage buffered output. It's 16 bits. I also know that ADI makes really, really good analog stuff. So I think if I'm going to design a 16-bit DAC board with STEMMA QT for I2C to 16-bit DAC out, I think that this is the this is what I'm going to go with. So I'm going to I can't order it right now, but what I will do is I'm going to add this to my so you can subscribe to get told when it will be back in stock. I think it was going to be a while. I don't know. It doesn't have a lead time even. And then when this is available, I can design the PCB and get it ready. And then when it comes into stock, I'll be able to design something with this. So the AD5693. So the nice person who mailed. This is the 16-bit DAC that I would pick.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right. Couple questions.
Yeah.
Do you have to define the STEMMA connector separate from the standard I2C in the board definitions, or is it the same for this board?
Oh, actually, this one does have a separate one, so I forgot to add it. So I would
Yeah.
add a separate SD.
All right.
I forgot
And then-
the C3 had the same, but the S3 doesn't. But I
And
would have
then-
noticed that when I checked all the pins.
Yeah, someone noticed the SC Cutie Pie appears to have 2 I2C, so she'll probably go back and add those to the pins when not on camera.
Yeah, usually it's like. By the way, I usually do not do board definitions on camera because it's like there's a lot of. I usually go
Yeah.
through the schematic and I'm like super careful and I check
Yeah,
every pin.
don't worry, this isn't live. We'll edit it in post.
Yeah.
Oh wait, it's live.
Well,
we never
yeah.
edit in post.
I mean, it is the beginning. This is how I start, and then I'll I do stuff like I test the NeoPixel port and the I2T port, so I
Yeah.
catch the mistake eventually.
This kind of goes with our theme. For years, no one's allowed to show the process of engineering. Mistakes are made. No one ever shows that because you don't want to appear that you make mistakes or you have to do updates.
I make mistakes all the time.
And we have to normalize this because this is one of the problems from computer security to everything else. Everyone just doubles down and they're unwilling to change directions when they get new information.
I totally made a mistake with this design, but you know what?
But the thing is, if we could all just get past
Yeah.
that, and what I've noticed is people would rather hide or even quit than just admit that there was a mistake and they got new information and just updated things and made it better. So I'm thankful that we have a good community and audience that we're all cool with this. It's like this is what it looks like to do engineering.
Yeah.
And we do it live. Every week we show things and we're like, oops, made a mistake. And I'm thankful that we have a place for that. I hope that we can become contagious in that way.
Yeah.
And more industries and more companies in our space consider just showing that sometimes, you got to make updates.
All right, well, that's what I'm up to. So I'm going to finish this Cutie Pie definition and order those PCBs. So you'll see those S3 chips and boards in the shop probably in about 2 weeks, which will be very exciting. So
right.
pick up some of our boards to help support us because, as you can see, it's very hard to get parts right now.
Yeah, please buy something from Adafruit.com once in a while.
Yeah, it
That way,
does help.
that way.
But I also try to make stuff that you
yeah.
want. I'm not like you don't do it out of charity, although you.
Well,
you
what's
can.
funny
You
is
should- you should get something good for it.
every video is like and subscribe, and that just helps YouTube really.
Yeah.
Which is fine, but you can just buy something from the Adafruit store, and you know exactly what's going to happen. We're going to turn it into electronics and pay our team.
All right, that's it. So let's answer any last questions and we'll get out of here.
That's it. Thank you so
All
much,
right, thanks
everybody.
everybody.
See you during the week.
Bye.